So, hi guys, how are you all? I hope you all are doing good and staying at your homes in these tough times of COVID and Omicron. And I just want to ask you, how is the quality of broadcast first? Then I'll introduce myself and I'll introduce about the course and what are we going to study today and other things. So, first of all, you can just rate the quality of the broadcast. That is, if you can hear me properly and if you can see me properly on the scale of 1 to 10, that is 1 for the worst and 10 for the best, right? So, in the next slide, I'll be asking you how is your preparation for your exams. Today, we'll be talking about the board exams. We'll be studying something different apart from JEE. We'll be studying about the chemistry for the board exams for your upcoming boards. So, how is your preparation? You can just rate it from 1, 2, and 3. That is 1 for the sad phase, 2 for the mild phase, and 3 for the happy phase. That is how confident are you in your preparations, and if you are confident enough to score full marks in chemistry, in maths, physics, and whichever stream you are studying, that is biology also. So you are studying well, then we are here to make your preparation even more better. So today we will be studying the topic of electrochemistry. Before that, I'll be introducing myself. My name is Khushang, and I gave JEE few years back, and I have cleared JEE with 99 percentile in chemistry, and my interest in artificial intelligence. I am in one of the most prestigious colleges of the country, right? So this was not at all boasting, it was just the way they have told me to introduce myself, right? So that's it. So today we'll be studying with electrochemistry. We will be revising electrochemistry uh, as far as we can go in that chapter, and we can revise that chapter in the coming lectures. We'll be completing the chapter, or in this lecture only I'll be completing the electrochemistry chapter if possible, right? So before wasting much of the time, we'll be starting with electrochemistry, right? So we'll not be going into the PPT. We'll be going into the PPT and reading it uh, after some time, but I'll be explaining you what actually electrochemistry is. Why do we study electrochemistry? What was the need of introducing the chapter like electrochemistry in our NCRTs, and why do we study it, right? So basically we have studied about chemical reactions, right? So in chemical reactions, we gain chemical energy. So there are many types of energies present, like nuclear energy, or and many types of energy is possible, right? So we if and the energy which comes in our daily use is the electric energy, or we can use the electrical energy to turn on these lights and to turn on the devices you are watching in this video on, right? So we basically needed electrical energy, so we had chemical energy, and we need to convert this chemical energy to electrical energy. And even we can convert the electrical energy to chemical energy chemical energy, right? So this topic is basically playing around these two, chemical energies and electrical energies. We are converting the chemical energies to electrical energies, and electrical energies back to chemical energies as per our choices, right? So uh, one thing I want to tell you is that when we convert the electrical energy, that is the chemical energy to electrical energy, right? Electrical energy, these types of reactions are spontaneous reactions. And when we convert electrical energy 2. Chemical energy. Chemical energy. These types of reactions are non-spontaneous reactions. Non-spontaneous. Right. So when we convert the chemical energy, that is we use the chemical reactions to attain some chemical energy and we convert it into the electrical energy. These types of reactions are spontaneous reactions, and when we convert the electrical energy to chemical energy, then these types of reactions are non-spontaneous reactions. So what are spontaneous and non-spontaneous reactions? Let us have a quick recap. I have told this in the previous chapters, and uh, okay, no problem. We'll be studying this once more. So, what are spontaneous and non-spontaneous energies? First, spontaneous energies. Spontaneous energies. Spontaneous energy or spontaneous energy, spontaneous reactions, you can say, right? So, what are spontaneous reactions? Spontaneous reactions are the reactions which occur on their own. Occur on their own. What does it mean? Occur on their own is the meaning that these reactions do not need any extra support or any extra factor, any external factors, any catalyst or any external force to happen. Right? Spontaneous. So what is that? That it occurs on its own. It occurs itself. So I'll be giving some real life example and you will be understanding with that. And vice versa is for the non-spontaneous reactions. Non-spontaneous reactions do not occur on their own. So we'll be writing non-spontaneous reaction do not occur on their own. That is, these types of reactions always require some external force, some external catalyst, something extra to add into them to make the reaction happen. It doesn't happen on its own. While in spontaneous reactions, they happen on their own. They do not need any external or extra force. Let me give you a live example for that, or a daily life example. The example is that if we have a mountain, right, and we have some water here down the mountain, and we want that this water should be at the top of the mountain, and in other example we have water on the top of the mountain and we want it to be at the bottom. So when this thing, that when the water is at the top of the mountain and we want it to come below the mountain, right, so it will flow on its own. It will not require any external force to make it happen, right? The water will not require any external force who can push the water down the mountain. It will flow down on its own. So it will be a spontaneous process, right? And on the other hand, when the water is at the bottom of the mountain and we want it to be at the top of the mountain, we need an external force. We need an external motor to be applied here so that it can carry the water up the mountain. It applies an extra force on the mountain so that the water can go up the mountain, right? So this is the type of spontaneous process. One second, let me write. This is non-spontaneous, non-spontaneous, and this is spontaneous, right? So so I've told you that converting chemical energy to electrical energy is a type of spontaneous process. Spontaneous process. So now we'll be studying with the definition of electrochemistry, and I'll be explaining you exact and each line of this uh, definition, right? So electrochemistry is the study of production of electricity from energy released. Study of production of electricity from energy released during spontaneous chemical reactions. So it is the study of converting the chemical energy released out of spontaneous chemical reactions to electrical energy, right? So this is electrochemistry and the use of electrical energy to bring about non-spontaneous chemical transformations. So some chemical reactions are there which are non-spontaneous. It requires an external force. So that external force would be electricity in some of the form, right? So we'll be applying electricity or we'll be applying electrical energy to make those non-spontaneous reactions happen, as they cannot occur on their own because they are non-spontaneous. It is very very simple that this electrochemistry revolves around electrical energy and chemical energy to electrical energy. I hope you guys have understood this. There are many uses of this electrochemistry. One of the uses is electroplating, which is very important, that we can use electrochemistry to plate metals on other metals, right? We can do gold plating, platinum plating, silver plating using electrochemistry. And we the other uses can be cells. There a major use of electrochemistry, a very major use of electrochemistry, and then in this chapter we'll be talking about cells. Most of the time, you can say most of the time we'll be talking about cells. And with the help of electrochemistry we can uh, the cell was invented basically. So without the cell, nothing I think can be possible. uh, Whatever we are doing today, it is not possible without the cell being invented in the past using this electrochemistry. So this was the actual need of studying electrochemistry. And yes, so we'll be moving forward. Before that, I'll be asking you if you have studied the redox reactions chapter, because the redox reactions are very important in these types of react in this chapter electrochemistry. So if not, you can revise the redox reaction chapters once, and I'll be just giving you the brief overview of that redox reactions. Basically, what were redox reactions? Redox reactions. What were redox reactions? The name says itself, redox. That is reduction and oxidation. Right? Reduction and oxidation. The reactions in which reduction and oxidation occur simultaneously or at the same time. Right? So these types of reactions are known as redox reactions. We can take a example and I'll explain you what is actually redox reaction and what is oxidation. The increase in the oxidation number or the giving of electrons, right? So uh, first of all, I just want to ask you and I just want to tell you to study about the metal activity series. Metal activity series given in your NCRT, in your chapter stoichiometry itself, and the redox reaction chapters. In the chapter in which redox reactions are given, there is a metal activity series. What is actually the metal activity series? The metals are written one by one in the metal activity series. So what does it denote? It denotes that moving from top to bottom, the reactivity of the metals decreases. So, for example, if zinc is written here and copper is written somewhat here, so zinc will be more reactive than copper. So, what does it imply or what does it suggest that what is the use of this? Uh, if zinc is more reactive than copper, then what do we do with it? Actually, what is oxidation? One second. Okay, what is oxidation? Giving of electrons. Giving of electrons. What is reduction? Receiving of electrons. So in a reaction, uh, if there is a reaction in which a metal requires some electrons and there is a metal which is able to give some electrons to other metal, right? So what does it imply? One second. Okay, so the oxidation is the giving of electron, and reduction is the receiving of electrons. This implies that, for example, in this reaction, zinc is more reactive than hydrogen. How do we know it? We know it by the metal activity series, right? So the zinc has an oxidation state. I'll not be explaining about the oxidation state. I hope all of you guys must have studied it in your before chapters. It in your 11th class itself. This is 12th class. We are preparing for your board exam. We are just revising the subject, so I'll not be going into the details. So you know what is oxidation number. So if we increase the oxidation number, how the oxidation number increases? By giving the electrons, right? So when someone gives the electrons, there must be someone who can take the electrons. So who will be taking those electrons? The metal which is below of the metal which is in the metal activity series, that is the metal which is less reactive than the metal giving out the electrons. So the hydrogen here is having an oxidation state of +1, so it has a plus sign and it can receive one electron. Zinc is more reactive than hydrogen, so it will be giving electrons, and hydrogen is less reactive, so it will be accepting the electrons. So zinc will be getting oxidized and hydrogen will be getting reduced, because zinc will be giving out electrons and hydrogen will be accepting the electrons. So in this reaction, simultaneously oxidation and reduction is going on. So this type of reaction is known as redox reaction. Redox reaction. So in which, in this reaction, if zinc is there are two hydrogens, so two electrons are required by these two hydrogens. Zinc will be giving two electrons. So if it gives two electrons, it will be Zn plus 2, and its oxidation state will be +2. Oxidation. Oxidation. And in similar way, when two hydrogen are accepting two electrons and converting into H2 gas, so reduction is happening, right? So in chemistry, everyone wants to be stable. Why this? Why everything this gaining and losing of electrons is happening, right? So this is happening because everyone wants to be stable. Everyone wants to be stable, right? So they are giving electrons. Some metals need the electrons, so they are receiving the electrons. Some are giving out the electrons to be stable, some are accepting the electrons to be stable. Who are giving the electrons? Who are more reactive, right? And who are receiving the electrons, which are less reactive in the metal activity series. So one more thing, the zinc here is getting oxidized. So how it is getting oxidized? Giving out the electrons, right? So it will be reducing the other element. Hydrogen here is getting reduced. How it is getting reduced? By gaining some electrons. So by gaining the electrons, it will be oxidizing the other. So the element who is oxidized is called the reducing agent, and the element who is reduced is known as the oxidizing agent. So here it is written that what is reduced is the oxidizing agent, and H plus oxidizes zinc by taking electrons from it, right? And what is oxidized is the reducing agent. Zinc reduces H plus by giving it electrons. So it is very simple. We have just studied about what are the redox reactions and what were the redox reactions, and just we will be studying a major redox reaction. The major redox reaction is zinc solid plus Cu plus 2 aqueous goes into Zn2 plus Cu solid. So the question here is, I'll be asking you a question that the question is, which element here is getting oxidized, which element here is getting, let me write the question. Oxidation, about, tell me about the oxidation. You can write in the comments, right? So tell me about the oxidation reduction is, which is the oxidizing agent, and D, what is the reducing agent here? It is a very, very important reaction. This reaction will be used in, you can say, most of the chapter. I'll be telling you how and why. So what is getting oxidized, what is getting reduced, what is the oxidizing agent, what is the reducing agent? So I hope you guys have solved it by pausing the video, and you have just put down in the comments that you have solved this part, and this is the answer to that. So I'll be solving this. One second, let me erase this first. Let us go to the previous page and we'll be writing this, right? So in the metal activity series, if we see, zinc is more reactive than copper, right? So zinc will be giving 2 electrons to copper, and copper will be receiving 2 electrons from zinc. So zinc is giving 2 electrons, it is getting oxidized by a oxidation state of +2. The change in oxidation state of +2, as 2 electrons are being exchanged, and copper is receiving the electrons from zinc, so it will be getting reduced by taking 2 electrons. So zinc oxidized, right? Copper reduced. What is the oxidizing agent? The element which is reduced is the oxidizing agent, as it oxidizes the other. Oxidizing agent is copper, reducing agent is zinc, right? So this was the answer to the problem. Moving ahead, we'll be talking about electrochemical cells. Main chapter is starting now. What are electrochemical cells? One second. One second. What are electrochemical cells? There are two types of cells actually. Okay, what are you saying? Okay, no problem. So we'll be studying about the electrochemical cells. We'll be not be studying about the electrovoltaic. Okay, so electrochemical cells, also known as the voltaic cell or the galvanic cell, because they were invented by the scientist Volta and Galvano, so they are known as galvanic cells and voltaic cells, right? So there is an example of that cell is the Daniel cell. Daniel cell. So Daniel invented electrochemical cells by in the search of converting the chemical energy to electrical energy. Right. So Daniel invented that cell to convert the electrical and the chemical energy to electrical energy. How did he do that? How did he do that? Actually, he took two beakers. One second, we'll draw it nicely. He took. It is very, very important, and you can just note down this. You will not be asked questions beyond this, right? So I'll be explaining you Daniel cell in very much of the detail, and you will not be asked questions beyond that. You will be asked questions from this only. So what we are studying about the Daniel, right? So in the first beaker, Daniel took a solution of ZnSO4. In the second beaker, Daniel took a solution of CuSO4. Then he put two metal rods in the solution. One rod here, then one rod here. Basically, we'll be converting the chemical energy into the electrical energy right now. I'll be explaining you what we'll do. So this is a proper metal rod. Right. This metal, which was this metal? This was zinc metal only, and this metal was copper. So he put zinc metal rod into ZnSO4 and copper metal rod into CuSO4. Then he took a wire and connected these two beakers, these two metal rods, right? And he took another wire and he connected a bulb with it, and the bulb started glowing. How and why? Right? How and why will be given by this reaction. Zn solid plus Cu2 plus aqueous will be going into Zn2 plus aqueous plus Cu solid. This reaction will be giving answer to that problem. How and why we can just know. So you know, when ZnSO4 solution is there, so it will be breaking down. ZnSO4 will be breaking down to Zn2 plus SO4 2 minus ions in the solution, and similarly in CuSO4 Cu2 plus SO4 2 minus ions will be there in that solution. So when we put a zinc rod in it, zinc is a highly reactive metal than copper. So this was connected by a wire. So zinc wants to be stable, as everyone wants to be stable. So the zinc in that metal rod wants to be stable, and it is dipped into a solution containing Zn2 plus ions, which are already stable. So zinc will be stable when it will be giving out 2 electrons. So very easily zinc loses 2 electrons. The zinc in that rod loses 2 electrons and forms Zn plus 2 and gets dissolved in the solution where all Zn plus 2s were there. So on that rod only 2 electrons are left from one atom only. There are many, the zinc rod is made up of millions and trillions of Zn plus 2 atoms, right? So Zn atom loses 2 electrons and forms Zn plus 2 and gets dissolved in this solution. So when the 2 electrons from one atom got released, the electrons have a nature of running here and there. So when the wire was there, the electrons started flowing in that wire. And here comes the part of copper. So similarly, copper, in the copper solution CuSO4, so copper is less reactive. It wants 2 electrons and it wants to form Cu. It wants two electrons and it wants to receive two electrons, as Cu2 plus will be stable when it will be receiving two electrons. When the case of zinc and copper will be there. If there is a metal which is less reactive than copper itself, for example, silver. If silver would be there, then copper will be giving two electrons and becoming stable, right? So in this case, zinc is more reactive, so zinc will be giving two electrons, and the copper solution, in the copper solution, Cu2 plus ions are there. It wants to be stable, it wants two electrons. So when Cu2 plus ions will be seeing that two electrons are coming from the rod, it will be receiving those two electrons and getting deposited on the rod. So by in this process, millions and millions and trillions of electrons will be flowing from this zinc solution or the zinc part of this cell created from the to the copper part, and copper will be accepting the electrons. And what is actually happening is the zinc rod is getting thinner because the atoms in of zinc metal is losing two electrons and getting dissolved in the solution, and the copper rod is getting thicker and thicker. Why? Because the copper from the solution of CuSO4 is getting deposited on the rod by receiving two electrons which are coming from the other side. So zinc is getting thinner and copper is getting thicker, but electrons are flowing continuously. And the flow of electron is the cause of electricity. So basically, we have converted this chemical energy to electrical energy. We have just used the chemical reaction, the redox reaction, and we have produced electricity. The bulb started glowing. We have produced electricity, right? But Daniel was very happy that is he just converted the chemical energy into electrical energy. He was the first scientist. He invented this cell, but he was just writing that in paper and the bulb stopped glowing. The bulb stopped glowing. Why and how? The question goes to you. So you can just pause the video and think about it. Why the bulb stopped glowing? I think I know your answer and that answer is wrong. You will be thinking that the zinc rod is getting thinner and thinner and zinc will be completely dissolved in the solution and the circuit will be getting incomplete. But it is not the case. This is due to attraction and repulsion of the electrons, and electrons are stopped from flowing. There is a negative voltage also created here. First point. Okay, we'll be writing points due to which the bulb stopped glowing. Bulb stopped glowing. First point was the circuit was incomplete. You can see whenever we draw circuits in physics, it is a complete circuit. But here in the case of cell, we are just connecting these two. Where is this? Where is this? Why the circuit is not complete? I'm sorry. I have just catched the cold. Right. So the circuit was incomplete, right? And the second point was there is a negative voltage created. How? By some ions. What are these ions? Let me show you. We'll be drawing the diagram again. There is a rod, there are two beakers, these rods are connected, or in these rods are these rods are connected, and there is a bulb, right? And this is a solution, this is a solution. This container is having Zn plus 2 ions and SO4 2 minus ions. This solution is having Cu2 plus ions and SO4 2 minus ions. Right. When the zinc here, zinc rod, copper rod, when zinc from the zinc rod is losing 2 electrons and Zn plus 2 are getting deposited in the solution, there will be a time when the concentration of those Zn plus 2 will be in a very huge amount, right? And here also, when Cu2 plus are getting deposited again and again on the copper rod, the positive charge here is getting depleted by time, so negative charge is getting increased. So electrons, which is a negative charge, is flowing from here to there, right? Electric current's direction will be here to here, as electricity is in opposite direction to the flow of electrons. So here negative charge is developed, here a very huge amount of positive charge is developed in this solution. So this positive charge will be attracting this electron and this will be repelling this electron. So it will be, these two forces will be stopping the electrons from flowing from left to right. It will be applying a negative potential from right to left. So there will be a time when this potential will be equal to the potential applied by this cell. The electrons will stop flowing and the bulb will stop glowing. I hope you guys have got it. Let me repeat this. There is a huge amount of positive charge here and a huge amount of negative charge here. Electrons are flowing from left, where there is a very much amount, there is a huge amount of positive charge, to the right, where there is a huge amount of negative charge. So there will be a time when the positive charge will be so much high that it will start attracting electron, and electron will be getting, you can say, it will be getting affected by that positive charge. And from on the other hand, there will be the negative charge. The negative charge will be increased in such amount of quantity that it will be repelling the electron in such a way that the electron will be affected by that negative charge also. These two forces are applied against the direction in which the Daniell cell is carrying the electrons. So there will be a time when this force will be equal to the electromotive force, or the force from which the electron is flowing. It will stop the electron, and the electron will and the bulb will stop glowing. So the cell failed. Now Daniel thought and thought and thought, and just he was thinking about how to glow this cell again. What is the actual problem? So he found that the circuit was not complete, and this was also getting, you can say, this was also, one second. Okay. So What he invented was a salt bridge. Sorry guys, there are a huge amount of disturbances today as we are working in lockdown for you guys, right? So we have invented, the Daniel, not we. Daniel invented a salt bridge. What was it made up of? It is very very important, it will be asked in your exam also. So he invented a salt bridge, and it was invented of agar agar. Very easy to remember, right? So it is made up of agar agar. No need to go into the constituents of agar agar. You can just uh, you can just conclude that this agar agar was built up of such materials. There was a U-shaped tube which he applied. Let me show you. I have, if we have like this. So this was the salt bridge, right? So this was the salt bridge. This is a U-shaped tube made up of agar agar. What did it do? First, it is a conducting a tube. It can conduct electrons. Second, it reduces the excess amount of positive charge there by reacting to it, and reduces the negative charge here by reacting to that as well. It was made up of such a material. You can just search down what is agar agar, and you can just see that it will be, the salt bridge is made up of such way that the Zn plus 2 collected here, the Zn plus 2 will be starting getting reacted from that agar agar and forming some compounds. So the positive charge will be getting depleted, and in the other hand, those SO4 2 minus ions will be also reacting to agar agar and forming such a compound that those negative charge will be getting depleted again and again and again. So by the time this positive charge will be getting reduced and that negative charge will be getting reduced, so that the external voltage which was applied due to these two charges will be getting reduced. So that due to that reduced voltage, the electrons will start flowing again, and the bulb will start glowing again, right? So by the use of this, we deleted that external voltage, right? So when we use this salt bridge, we completed the circuit. We decreased those external voltages, or the effect created by those ions, and the bulb started glowing again, and it glows forever, you can say, right? So one second, we have used the salt bridge. So we'll be studying about the galvanic cells. In this device, the Gibbs energy of the spontaneous redox reaction is converted into electrical work. Gibbs energy, which we are already studying here, G delta G naught, you can say, right? And which may be used for running a motor or other electrical gadgets like heater, fan, geyser, or anything. We have converted electrical energy, right? We have generated electrical energy from chemical energy by those simple redox reactions, right? So Daniel cell discussed earlier is one such cell which will follow the redox reaction. I have told you, Zn solid plus Cu2 plus Zn aqueous plus Cu solid, right? This reaction is a combination of two half cell reactions which gives to the addition. So Cu2 plus is gaining 2 electrons and getting converted into Cu solid. It is the reduction half reaction. And Zn solid is getting converted into Zn2 plus and giving out 2 electrons which are accepted by this copper, and it is the oxidation half reaction, because in this the copper is getting reduced, Cu is getting reduced and zinc is getting oxidized. Right, these reaction occur in two different portions of the Daniell cell. I have told you we use two beakers. The reduction half reaction occur in the copper electrode, because copper is getting reduced, so reduction half will be in the copper electrode. Is very, very simple. What is electrode, what is electrolyte? First you can it is very, very important. This was the beaker, this was a metal rod, and this was a solution. This solution is electrolyte, and this metal rod is electrode. You get it? This copper solution, this zinc solution, ZnSO4 solution, these are the electrolytes, and this metal, this copper rod, zinc rod, these are the electrodes. So what is written actually here is that the copper electrode, this electrode, you can say the copper metal rod, we here we are talking about the copper metal rod, while the oxidation half reaction occurs on the zinc electrode. So oxidation reaction occurs on the zinc electrode and the reduction reaction happens on the copper electrode, right? So these two portions of the cell are also called half cells or the redox couples. They are known as the redox couples or the half cells, right? The copper electrode may be called the reduction half cell and the zinc electrode is the oxidation half cell. So where the oxidation is happening is known as the oxidation half cell, and where the oxidation is happening is the reduction or the oxidation half cell, right? So we'll be moving ahead. We'll be studying about the potentials or the electrode potential and the cell potential, right? So what is the electrode potential? One second, you can just note down all this. I'll be giving you some time and you can just note down. Okay, right, so we'll be studying about the electrode potential now. What is the electrode potential? I have told you what is the electrode. The metal rod was the electrode, so we'll be studying about what is electrode potential. Electrode potential, right? What is the electrode potential? We'll be writing the definition. You can just note down, it is very important. Potential difference developed between the electrode and the electrolyte. Potential difference between the electrode and the electrolyte. So if there is, this is ZnSO4 and this is the zinc rod, this ZnSO4 is the electrolyte, right? And this zinc is the electrode. right? So the potential difference between this zinc rod and the solution, as solution contains ions and zinc rod is having a potential due to the flow of electrons also and something like that. So the potential difference between these two is known as the electrode potential, right? So there is a standard electrode potential also, right? First of all, before that, if we take the example of a Daniel cell, of this Daniel cell cathode, Daniel cell, for example, Daniel cell. The cathode, what is the cathode and what is the anode? What is the cathode here? Cathode, where first again there is a shortcut, or you can say there is a reduction and oxidation, right? So what is the cathode? The cathode will be copper part, and what is the anode? The anode will be the zinc part, where the oxidation happens. So oxidation happens at the anode and reduction happens at the cathode. So the shortcut is red cat. What is red cat? Right? Reduction at cathode. This is the shortcut, that red cat. So we'll be remembering that if red cat, we remember red cat, so we know that reduction happens at the cathode, so obviously oxidation will happen at the anode. So we were writing about the electrode potentials, right? So coming on to the electrode potential in the Daniel cells, cathode will be having a positive potential with respect to solution, and the anode, where what happens, oxidation, will be having a negative potential with respect to solution. You can just note down this, right? What is the standard electrode potential? Standard electrode potential, we'll be studying this electrode potentials. First we'll be studying with standard electrode potential. What is the standard electrode potential? Electrode potential, when the concentrations, electrode potential, let me type electrode potential, when the concentration of all the species present or involved in a half cell is unity. You can just remember this, or you can just understand this, that the electrode potential is the potential of a half cell only. If we consider the two beakers and we consider this whole apparatus as a whole, it is the complete cell, and if we divide it in half, we have two half cells. So in this half cell we have the solution and a metal rod. So if we measure the potential difference between that rod and that solution in this half cell, it is the electrode potential. And similarly, if we do here, there is a separate electrode potential in the other half cell. So this is the electrode potential. And if all the concentrations are unity in this half cell, if the Zn is zinc, Zn2 plus concentration, SO4 2 minus concentration, Zn solid concentration, all are unity, so it will, and the temperature is at the standard, that is 273 Kelvin, and the pressure is 1 bar, everything is at standard conditions, then that condition is known as this, and the potential calculated at that condition is known as the standard electrode potential of the half cell of that particular cell. There are many other cells also, right? So there are two types of standard electrode potential, two types of standard electron potential, two types: oxidation, standard oxidation electrode potential, and standard reduction electrode potential. This SOEP, what is SOEP? Standard oxidation electrode potential is denoted by E, and there is a knot here, and M converted into N positive, where N electrons are exchanged. For example, in that Daniel cell, we have seen in the half reaction, zinc is getting converted into Zn 2 plus 2 electrons. So M here is getting converted into M and N positive, and this is N electrons here, right? So here oxidation is happening. So standard oxidation electrode potential is denoted by this E with a knot, and in the, you can say, in the subscript we are writing what is actually happening. The metal is getting oxidized, it is losing N electrons and getting converted into Mn plus. And similarly, when we write S O R P, we'll be writing E not M N plus first, and is getting converted into M. For example, in the Daniel cell, we have seen that Cu plus 2 takes 2 electrons and gets converted into Cu solid, right? So the metal ion gets N electrons and gets converted into metal. So this is reduced. So the standard reduction potential is this, and the standard oxidation potential electrode, the standard oxidation electrode potential is this, is denoted by this. So now we'll be studying about the measurement of the electrode potential. The potential difference of individual half cell cannot be measured. The potential of individual half cell cannot be measured. We can measure only the difference between the two half cell potentials, that gives the EMF of the complete cell. Okay, one second. What we have, I have told you about the electrode potential, right? Now we'll be studying what is cell potential first, and now then I'll be explaining you what is written. Cell potential. What is cell potential? Potential difference between two electrodes. Potential difference between two electrodes of a galvanic cell. I've told you about what was electrode potential. We were calculating the potential of a half cell of the electrode in a half cell, and we have calculated in the anode also, in the cathode also. Anode where oxidation happens, cathode where reduction happens. So we have calculated the standard oxidation reduction potential, the standard oxidation electrode potential, and the standard reduction electrode potential. We have the electrode potentials of the two half cells. Now if we want to calculate the potential of the complete cell, so what we'll be doing is we'll be calculating the difference between the potentials of these two half cells. When we will be having the difference between the potentials of these two, anode and cathode, we'll be having the potential of the complete cell, the potential it will be providing of the complete cell. You can note what when you bring batteries from a particular shop, the battery is like, there is a positive terminal, there is a negative terminal. They are having two rods in them. The one is anode, then the one and the other one is cathode. These two are some electrodes, and they are having some potential differences, and the difference between those potential difference is written outside the battery. The battery provides that difference, that potential, which is the difference between those negative and positive terminals. Now you get it, where what is written 9 watt, and then when you bring 9 volt battery, 9 volt is written. What is that 9 volt? It is the potential difference between the electrodes of that battery, that is the negative and the positive potential, that is the negative rod and the positive rod, or the anode or the cathode. The cathode is a negative rod, anode is the positive rod. Anode, oxidation happens. Cathode, the reduction happens. The potential, we calculate the electrode potential of the cathode, we calculate the electrode potential of the anode, and when we take the difference of these two electrode potential, we have the potential of the complete battery. So this is the phenomena of electrochemistry, that we have converted the cell, we have invented the battery, where the chemical reactions are happening continuously, the redox reactions are happening, there is a salt bridge inside, there are two electrolytes inside, there's solutions inside, and there are two electrodes inside also, and this all is happening. And when we have a battery product, that is a cell. Inside this, I have told you what is actually happening, what is the actual you can say the structure of that battery, what is, how the electrons are getting converted, how those 9 volts are getting formed, how you can get the 9 volts from the battery, how it is generated, right? So this was the electrode potential and the cell potential, right? So we'll be studying once uh, the only difference between the two half cell potentials, that gives the EMF of the cell. If we arbitrarily choose the potential of one electrode, then that of the other can be determined with respect to this. Obviously, if we have the cell potential and we have the potential of one electrode, then obviously we can deduct that from the cell potential, and we'll be getting the potential of the second electrode. It is very simple. According to the convention, a half cell is called the standard hydrogen electrode. We'll be studying it in another lecture. We'll be studying about the SHE, standard hydrogen electrode. As I have told, as it is written, that we cannot measure the electrode potential, we cannot measure the potential difference between the electrode and in electrolyte in practically. So we just take a standard electrode potential of the hydrogen, standard hydrogen electrode we take, in which the electrode potential or the standard oxidation potential and the standard reduction potential is 0. So we take it as standard and we just calculate the difference between them, and we have the electrode potential. Also, we'll be studying about the SHE or standard hydrogen electrode in coming classes. The standard hydrogen electrode consists of a platinum. So okay, we'll be studying this in another class. So I think that's it for today. I hope you guys have understood what I have taught you. I am sorry for some disturbances in between. Actually, my I have just got cold in this cold weather. Everyone gets that. There is not big of the much of the problem. I have explained you the topics in very much of the detail. I hope you guys have got the topics, and I hope you will be studying for your board exams really well. More videos are coming soon. I'll be explaining you more chapters. We'll be studying chemical kinetics very soon. We have studied electrochemistry. We studied half of the electrochemistry. We will study Nernst equation with the standard hydrogen electrode and some of the topics which are left in some other class, right? And we'll be completing this electrochemistry chapter, and I hope you guys have got that and you'll get great marks in your board exams. So till then, uh thank you and bye bye.